Now, so Cn becomes A, N. Now, which rule is that? Cn, Cn, Cn. Yeah, here, this rule. Okay. So Cn becomes is substituted by An. So you overwrite, if you like, Cn is then An. So Cn becomes An. All right. Now we have three variables we can choose from. Now, which one will we substitute? Well, let's substitute this variable for our first terminal. So big A will be substituted by little a. Where's that? Here. That's this rule here. Okay. Big A gets substituted by little a. So it's that rule. Okay. Now what are we going to do? Well, something similar. So now we're here now. This is what we have currently written down here at this point in time. So now we're going to substitute N for the terminal boy. So which rule is that? So N goes to boy. N, here, this rule here. N goes to boy. Alright? Hope you can see that. So N goes to boy. So N goes to boy. So now you've got this R boy and then VP. Now you only have one choice: terminal variable. So you only have one variable. So that VP will have to be the one you substitute. Okay. So you're substituting VP. That's a verb phrase. Into CV, which is a complex verb. Complex verb. And this, which rule are we using? So VP to CV. VP to CV. So that's this rule here. You're using that rule. So you'll substitute VP by CV. So your VP will become CV. Alright? And then, so again, you've only just got one variable, so you now substitute CV for V. So a complex verb becomes a verb. So in other words, CV arrow V. Where's that? Here. You're using this one. CV arrow V. You're using that rule of substitution. Okay, so CV gets overwritten, substituted by V. Right? Just verb. So again, only one variable. So this you substitute that. You overwrite that with something. So and what is it? Well, it's C's. So V arrow C's is the rule you use. So where's that? V arrow C's. Okay. V arrow C's. And now you have a string that consists. All its symbols are terminals. So you've finished the derivation. Okay? So quite a few steps. This whole thing is the derivation, as it's called. You start with the start state, and you end with where all the symbols in what you have written down, they're all terminals. Okay? So start state to terminal strings, so to speak. Okay. All right. So we've done two examples of playing with grammars. So you've got an idea now of how a grammar works, how you can generate a string from the grammar, okay? And the set of all strings that you can generate from the grammar, that's the language generated by the grammar, okay? So you can talk about the language of the grammar, and that means it's the language generated by your grammar. So we were talking a bit about that before. So you've got an idea now of what a grammar is, what the language is generated by a grammar. So now we can move on and give a formal definition of a grammar, well, a context-free grammar, a CFG. Okay, so we're dealing now with a formal definition of a CFG. So this is definition 2.2, as usual. The first number is the chapter number, and 2, well, it's just the second thing, whatever it is. that gets a numerical ID in that chapter. Like as I was saying in the previous chapter, this number here could refer to a definition, an example, a theorem, a corollary, a claim, whatever. Okay, and Sipser uses global ordering. Thank God. Things that when you're referring back to something that has a numerical ID, it's easier to find if everything's in just the same order. Okay, so definition 2.2, we're giving a formal definition now of what a context-free grammar, a CFG, is. It's a four-tuple. In other words, a K, you remember, what, 2 chapters back, in chapter 0, in the preparatory chapter, a K tuple is just a list of K things. Right? It's simple as that. So here we've got 4 tuples. We've got 4 things that will be our definition of a formal definition of our grammar. Now you can probably guess what those 4 things are. Right? It's pretty obvious, I guess. I mean, what is a grammar? Well, it's the list of variables, right? It's the list of terminals. It's the set of rules and the starting symbol. Right? With those 4 things, you can generate all the language's strings, in principle. There are probably an infinite number of them, often. But they're the 4 things. So here's your 4 tuple with those 4 things. So V, that's your finite. Where is it here? It's a finite set of variables. Okay. So a context-free grammar is a finite. It's finite. That's not made explicit. Sometimes I think aloud. That was not made explicit by Sipser. Anyway, all right. So V is a finite set of your variables. Okay. Capital sigma now is a finite set of your terminals, and those. So variables are symbols and terminals are symbols, and the terminal symbols are distinct. They're not the same as the variable symbols. Okay. So in other words, this set and this set are totally disjoint. They have no member in common. Okay. You can't have a variable that is you cannot have a symbol that is both a variable and a terminal. Symbols one or the other. So these 2 sets, finite sets, are disjoint. Okay? They have no memory in common. Okay, 3. Now, why on earth? Why wasn't that labelled capital T? T for terminal. You've got V for variable. Well, I suppose the tradition of using capital sigma for why is that? See, before capital sigmas, in the context of the previous chapter, was used as your alphabet. Now, the symbols that you could have in your input stream. Chapter 1, talking about finite automata. So I suppose he's keeping that convention. This sigma now is the set of terminal symbols, and somewhat analogous to the set of symbols, lowest level, if you like, symbols in your alphabet. So I guess it's for that reason. Anyway, but query, why isn't it just capital T? Now capital R, obviously a set of rules, your substitution rules. And capital S is the start variable. So this variable, this symbol here, which is a variable, will be one of the members of your V. So S will. Now V is a set. That's a set. That's a set. This is not a set. It's just a variable. So this is a member of V. Okay. So R's your finite set of rules. Okay. And the rules consist of like a variable, and usually an arrow, and then a string of, well, it can be a mix. It can be a mix of variables and terminals, right? On the right hand side. And for S is your start state, and it's a member of V. Right? So it's just one of the variables, but the one you start with. So sort of emphasize. I mean, strictly you could have just a three tuple, you know, triple, because S is a member of V. But it's so important because you always start with a start variable, so it's given special status. It's a special variable. It's not like the others. Okay, so it's your fourth term in your four tuple. Right. So that's your formal definition of a CFG, a context-free grammar. Yeah, I think I'll stop there because there's quite a long sentence. This is the first line of quite a long sentence. So I'll stop there and just move straight on to the next session.